Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about bilinear method of designing an IR filter. We can design an analog filter. After that we are going to convert a digital filter by using the method of bilinear transformation. So first steps to design a digital filter using a bilinear transformation. So from the given specification, first find the pre-warping analog frequencies using the formula omega equal to 2 by t into tan of omega by 2. See, these pre-warping will be done for an eliminate the warping effect. So in normal filters, due to the higher frequencies, the linear relationship between the frequencies and the response will be not available. So to avoid that, we are performing a pre-warping by using this formula. Second step, using an analog frequencies, find h of s of an analog filter. So finding an analog filter transfer function is the second step. Third step, select the sampling rate of digital filter, that is called T samples per second. We can assume it if it is not given as t equal to 1. And last step, substitute s equal to 2 by t into 1 minus z inverse divided by 1 plus z inverse in the transfer function obtained in the step 2, that is h of s. So in h of s, all the s should be replaced by 2 by t into 1 minus z inverse divided by 1 plus z inverse. This is a very simple method of designing an IR filter. Look at this given bilinear, that is given transfer function is h of z equal to 2 divided by s plus 1 into s plus 2. They asked to apply a bilinear transformation and assume t is equal to 1 and asked to find h of z. So first thing, given h of s equal to 2 divided by s plus 1 into s plus 2. So this is a transfer function that will be there given. So we need to simply substitute it, s equal to 2 by t into 1 minus z inverse divided by 1 plus z inverse in the h of s. So all this function, we have an s plus 1 and we have an s plus 2 now. These s should be replaced by this 2 by t into 1 minus z inverse divided by 1 plus z inverse. So h of z equal to h of z, where s should be replaced by 2 by t into 1 minus z inverse divided by 1 plus z inverse. So that we can take this 2 divided by s plus 1 into s plus 2, where s equal to 2 by t into 1 minus z inverse divided by 1 plus z inverse. Now I am going to substitute it. So we have 2 divided by 2 into, look at this. So 2 divided by, we have s plus 1 into s plus 2, we have this. So we have 2 divided by 2 into, we have s in now. So 1 minus z inverse divided by 1 plus z inverse plus 1 into 2 into 1 minus z inverse divided by 1 plus z inverse plus 2. Look at this. So only we have these two values. 2 by t only I am taking. So t is equal to 1. So I am getting 2 into this term only. That's why each s should be replaced by 2 into 1 minus z inverse divided by 1 plus z inverse. Look at this. So instead of s, I am replacing this value. Here also instead of s, I am replacing these values. So now we can normalize this value. So this denominator, both we have a same thing. So just cross multiply it. So here we have a 1 plus z inverse now. So cross multiply it. Here also we have 1 plus z inverse. That should be multiplied with 2. And then we need to combine it. So if we combine it, we are getting this 2 into, there is a numerator value. Denominator will be commonly be taken for both. So here we get a 1 plus z inverse. Here also we get a 1 plus z inverse. So multiply it, you get 1 plus z inverse square. That's why 2 into 1 plus z inverse square we have it. Denominator side we get this. This is for 3 minus z inverse. This is for a first term. And second term we get only 4. So this is the thing available. Now I am removing this 2 and 4. So what we get? 1 plus z inverse whole square divided by. So this 2 is cancelled with this 4. So multiply with this. So you get 6 minus 2 into z inverse. Now I should have a formula of 1 minus some terms of z inverse. So that I can realize directly. So that's why I am going to take a common term. After that common term, that will be taken to the numerator. Look at this. So here I have a 6, here I have a 2. So in this 2 function, I need to take a common as a 6. So if I take a 6 common here, what I get it means 1 minus, so here I have already have a 2, I am going to take a 6 common. So this will be 2 by 6 only becomes. So 2 by 6, that will be equal to 0.33. So 2 by 6, because I need to take a 6 as a common for both terms. So I need to take here also, again here also. So that's why I'm writing here as an 6 by 6, here as a minus 2 by 6. I'm taking a common values. So if I take a 6 common value, so you get a 1, that is 1 minus 2 by 6, that is equal to 0.33 into Z inverse. This is the denominator term. After taking the 6 common, that the 6 should be bring it to numerator. So here I need to bring a numerator, means it becomes 1 by 6. So 1 by 6 is 0.166. Remaining terms I am keeping it 1 plus Z inverse whole square. Why I am doing this means, so then only I can realize the function directly. So I need to have always the filter function is 1 minus some terms of Z power minus 1. That's why whatever the term available in this value, that should be taken as a common for all the terms, and that should be bring back to numerator for an easy realization. Thank you.